Hi, my name is Jasmine Bryan. I'm from Madison County High School, and my project is utilizing Eukaryotic Saccharomyces cerevisiae as an electricigen in both pure and co-culture in the anode of a microbial fuel cell. As society continues to use non-renewable fossil fuels, we must make changes toward viable green alternative energy resources. Microbial fuel cells have been given renewed attention because of their ability to generate electrical energy via microorganisms. I developed a small-scale general proof of concept for a grander-scale MFC design in the future utilizing the understudied yeast as an electricigen, an emerging idea of co-culturing in the anode of a microbial fuel cell for a higher voltage. I then developed my hypothesis. If a co-culture of Saccharomyces cerevisiae and Escherichia coli is a viable candidate for electricigens in the anode of a microbial fuel cell, then the average voltage produced will be at or higher than the average voltage produced in a microbial fuel cell powered by pure culture of Escherichia coli and or pure culture of Saccharomyces cerevisiae. So for my project, I utilized a dual chamber structure consisting of a cathode, anode, and salt membrane. I used two organisms which were implemented as co-culture and as pure cultures. For this, I used yeast, which was, it's actually had very few studies conducted on it. And then I also used E. coli because unlike yeast, it's had a lot of studying with it. And like I said, I did those as pure cultures and then together as co-cultures. I did three groups, those making up the three groups of pure culture of yeast, pure culture of E. coli, and then co-culture yeast and E. coli. There were 3 trials for each group, and for each one of those, I then submerged the electrodes into the anode and cathode after the inoculation was done, and then from there, I connected the alligator clamps to the copper wires, and those were connected to the data loggers. The data loggers recorded for 24 hours, giving me a data point of every second. A data point would be the voltage reading, and there ended up being over 900,000 data points recorded over the entirety of this experiment. From there, I then did my data analysis after I collected the data from the data logger. This is pictures of my experiment. The middle picture here, this is showing the main setup. You can see the MFC there. It's got the alligator clamps connected to the cathode and the anode. The black is connected to the anode and the red is connected to the cathode. The air pump is then also connected to the cathode, and it is sitting in a tray to help in case there is any leaking. You can see in the top right picture there an example of some of the leaking that was experienced. This was from trial 3 in co-culture, and it was the most severe leaking that ended up happening. So the tray helped any of the liquid from getting all over the floor. So the first experimental group was pure culture E. coli, and this ended up having over 300,000 data points. The trial 3 ended up having the maximum voltage of 2.9, and it had a mean voltage of 2.22. Or 0.22, excuse me. Then the second experimental group of pure culture yeast ended up having over 200,000 data points. The trial 2 ended up having a maximum voltage of 0.31, and it had a mean voltage of 0.16. The third group consisted of co-culture, which was both yeast and E. coli, and it ended up having over 200,000 data points as well. For trial 2, the maximum voltage was 0.37, and the mean voltage was 0.16 or 0.28. So these next slides, this is going to be covering the overall results. So the graphs are going to display the 24-hour overall results. And then the tables, this is the peak production from the time the alligator clamps were securely connected to the copper wires to when the peak production stopped, therefore whenever it hit 0 or started to plateau. For trial 1 here, you can see that there was a lot less data points collected compared to the other trials. The reason this is due part to the data logger was set to record every minute rather than every second. I ended up replacing this data logger so that in the next previous trials that it recorded every second. Same thing here. This is for once again, the 24-hour overall periods. That's what the graphs are displaying, voltage over time, and then the peak production from the start, from when they were connected to when they started to plateau and or hit 0. And then this one is for CoCulture. The past two were for pure cultures. This one for CoCulture, you can see here in trial 3 that there was this one ended up having this one, if you refer back to the fourth slide where the pictures are, you can see that this one was the one that actually had the most severe leaking. So it did give off some random readings there. So I ended up calling this one early since there was next to no liquids left in the MFC and since it was giving random readings. And once again, there's also the peak production from the time when it was connected to when it ultimately ended up plateauing. So next we have the two-sample pair t-test. For this slide, this is comparing the mean voltage produced during the peak production times. For the first t-test up top, it is comparing the pure culture yeast to co-culture yeast and E. coli. And for this, when I compare the t-value to the critical value, two-tailed 5%, this trial rejects the null hypothesis, and my alternative hypothesis has statistical merit. But then whenever I'm comparing the pure culture E. coli to co-culture yeast and E. coli in the second t-test, when I was comparing the t-values to the critical values, two-tailed 5%, this trial fails to reject the null hypothesis. Yeah. Then moving on to the next two-sample t-test, these both on this slide are comparing the maximum voltage. So both of the top one is pure culture E. coli to co-culture, and then the bottom is comparing pure culture yeast to co-culture yeast and E. coli. Both of these, when I was comparing the t-value to the critic value of two-tailed 5%, both of these trials ended up failing to reject the null hypothesis. So basically, just to kind of go over a lot of this and sum it all up, the highest average maximum across all the trials was in co-culture at 0.31 voltage. The only t-test, there were 4 t-tests conducted, and only one of the 4 ended up rejecting the null hypothesis. And that was when I was comparing the mean voltage produced in MFCs to co-culture, producing pure culture MFC yeast to MFC in the co-culture yeast to E. coli trials during peak production. My alternative hypothesis that CoCulture and Saccharomyces cerevisiae and Escherichia coli is a viable candidate for electricigens in the anode of a microbial fuel cell because the mean voltage produced across all trials is higher than the mean voltage produced in pure culture yeast and has statistical merit. While the voltage is low, there is potential that MFCs in the future can be developed and be able to produce a much higher sustainable voltage. For mine, this was conducted on a small scale, so the voltage was lower. Yeast, while it can be used as a pure culture, it does show more promising being implemented in a co-culture in the future. Moving on to what I would do in the future. So one of the things I would do in the future is, as I mentioned, there was some severe leaking in one of my trials and some minor leaking in others. So I would definitely try to get that structure as good as possible. So in the future, should I do it again, there won't be any leaking or next to none. I would also even like to experiment with some different materials. There's for the materials I was able to use, that's what I had to really work with. But for MFCs, there's a lot higher, more expensive materials such as gold and platinum that I don't exactly have access to. I would also even do more data analysis working with current and amps and things like that. I wasn't able to because of the time restraints on this project, but definitely in the future, that was something that I would add on to with this. And also, like I said, there were some problems with my project, so I would definitely, more trials are definitely needed for this to understand and be able to work towards a more durable, reliable, and viable MFCs for in the future. So that is the end of my project. Thank you for listening. My name is Jasmine Bryan.